One thing we're going to see pretty quickly is that arrays and pointers actually have a lot in common. We'll start talking about that next week. But you might remember from pointers that we spent all this time piling on all of this new notation like int star and float star. And then just when we got through all of that and all of the permutations of how to use that, without even having a chance to catch our breath, we suddenly started talking about int star star. And the idea that we can create pointers to any type, even if that type is itself a type of pointer. There is a similar progression that happens with arrays. Now, to be clear, this isn't related to int star star or to these pointers with more than one star, but it's interesting to see how the progression applies. And I think with arrays, the progression is actually a great deal more clean. I think this next topic is pretty intuitive to people. So we've seen already that we have the ability to create arrays of values, which is a single variable that corresponds to a sequence of some fixed size. So we choose a size, we declare a variable, the array then has that size forever. And we know that if we declare an array with the typical notation, so int a with size 5, what we are creating, and there's int, it's an integer array, and it starts pointing to this, and then having size 5 allows it to have 5 elements that are numbered with indices 0, 1, 2, 3, and 4. All right, so we have the ability to construct this sequence of elements. And you might notice if you're taking Math 110 or something that this seems very similar to the way I might represent a vector. And it is, and it turns out that assignment 4 is going to spend a lot of time on that. But then there's that natural question. What if I don't just want some linear sequence of values? What if I want something like a grid? And of course, this is the natural way you might represent something like a matrix. So here, I have a grid that has 3 rows and 4 columns. And the question is, how can I represent that? And there is a short answer and a long answer. The short answer is what we do in practice, and the long answer is what it really means in C. So the short answer is we have the ability to create what is called a two-dimensional array, as I'm sure you probably guessed from the fact that the prompt has been sitting there for the last 5 minutes. And we create a two-dimensional array by using 2 sets of square brackets when we declare the array. So here it is asking for a two-dimensional array, which should be named Q, and it has 3 rows and 2 columns. And we represent it like this. And so on my diagram, I would probably write this. Now, ideally, I mean, when you're given tracing questions, we try to keep the number of 2D arrays pretty low because we know that tracing through with that amount of stuff can be pretty unpleasant. So what I'm going to do is I will draw myself a 2D grid with 3 rows and 2 columns. And then, to be clear, the way we represent this is we represent the variable as an arrow pointing at the very top corner element. And I will clarify why I use the top corner for that, because each row and each column have an index, not unlike the indices we would see in a one-dimensional array. So the columns are indexed starting at 0, as you'd expect, and so are the rows. This would be row 0, this is row 1, and this is row 2. And so if I want to fill up this array with values, I have to refer to each element of the array with 2 coordinates, a row number and a column number. So that's the short answer. If I want to represent a 2D grid of values, which I could use to represent anything I wanted, I could use this to represent a map, I could use this to represent a matrix, whatever. It's just a way of representing data. If I want to do that, what I want is one of these 2D arrays. Okay, so what's the long answer? What exactly is this? Is C just a language with 1D arrays and 2D arrays, or is there something else going on here? Well, it turns out that just like the usual typing logic in C, just like how you can create pointers to any type, you can create arrays of any type. And formally, this is trivia for this week, but it'll come back on us later. Formally, it turns out that what Q really is an array of arrays. Q is an array of 3 arrays that contain 2 elements each. In other words, an array of 3 rows. And it turns out that you can create an array of arrays if you want to, a 3-dimensional array or a 4-dimensional array. And I will add, in my personal experience, I don't recall using 3-dimensional arrays for very much. They show up every now and then, but just like pointers with 3 stars, it tends to be the case that if you need that number of dimensions, you should be rewriting your code to organize data differently. But they can exist, and that's important to understand that the C language doesn't even know what a 2D array is. All it knows is what's an array. And we can use the power of the language, the ability to create arrays of anything, as a way of creating two-dimensional arrays. So here I've created an array called Q that has 3 rows and 2 columns, and the usual logic applies. If the size of a dimension of the array is 3, so that's the number of rows, then the maximum index is 2, because indexing starts at 0. Now, one other quick note before I continue. I keep calling Q an array that has rows and columns. And maybe if you look at this, and maybe if you agree that the C language doesn't know what a rectangular grid of numbers is, it doesn't care. What it thinks I'm working with here is an array of arrays. That is it sort of arbitrary that I've decided that the first dimension, the outer dimension, is the number of rows, and the inner dimension is the number of columns? And the answer is yes, that is arbitrary. And the reason that I choose to represent rows as the first number and columns as the second one is because if we work with things like matrices, we typically specify indices in row first and then column. And so this is a convention, to be clear, but it is one that we adopt rigidly. In this course, if we use the word row, I am referring to the first of the two dimensions, always, unless for some reason I say the opposite, which I won't, because that's unnecessarily confusing. It is true that that's arbitrary and that's a convention, but it's one example of a convention that we have to agree upon now, or else it'll be impossible to communicate about things. So in this course, it is not a valid grounds for mark appeals to say, oh, I'm sorry, I thought that this was the number of rows. Nope, that's the number of columns. We have to agree on the basic language that we're using. Okay, so the next question is, how do we put things into a two-dimensional array? Or more generally, how do we work with the data inside it? And I've prepared something earlier because I don't want to have to type this all out from scratch. So each dimension of our array Q is indexed separately. If I want to refer to, for example, row number 2, column 0, which would be this here, then I have to index twice. So I start at Q and then I index into row number 2, and then inside row number 2, I index into element 0. And I interpret that to mean row 2, column 0. And contrast that with if you had a matrix called Q, how you would index that matrix with row 2, column 0. You might start counting at 1 if you're working with matrices, but the indexing convention is very similar. But notice that in C, we don't stick a comma in the square brackets because we already know commas are bad business. Instead, we use 2 sets of square brackets, 1 for each dimension. And we'll see in the next week, in the next couple of weeks, implications of this. What really is happening when I use only 1 set of square brackets versus 2. But for now, if you have a 2D array, you should expect to be using 2 sets of square brackets. And just like with a 1D array, once you attach those square brackets, the thing you're dealing with behaves just like an element of that type. So Q is an array of ints with 3 rows and 2 columns. If I refer to a specific element, like this one, then what I'm doing is no different than referring to an int variable. Now, the next thing I want to do is fill this array up. So, row 0, column 0 equals 5. Row 0, column 1 equals 2. Row 1, column 0 equals 6. Row 1, column 1 equals 10. Row 2, column 0 equals -1. And then the other element there is 187. So that's what this would look like on my diagram. And I guess I forgot earlier to draw in that Q is an array of a 3x2 array of int. It's important to have this because that way if I use the name Q, I know what kind of element I'm going to end up at. All right, next. So the way I like to present 2D arrays is that they're not really different from 1D arrays. You index them, you create them, they have a size, and you index them. When we pass them into functions, which we'll see in a future video, it behaves no differently than a 1D array, really. So I don't want to belabor the process of the basic mechanics of a 2D array because it's not too different from a 1D array. But I want to show the kind of loop that we typically write if I want to iterate over this entire 2D array. And what you should observe is that because there are 2 indices, if I want to loop over the array, I guess I need 2 nested loops. One to take care of each row, and then inside of that, one to take care of each column. And actually, I could put the column loop on the outside. Maybe we'll come back at the end and think about that. So what I want to do is iterate over my 2D array Q. And I'm going to, for the sake of clarity, normally if I'm writing my own code, I would use I and J as the name of my variables. But because we haven't seen 2D arrays before, let's use more verbose variable names. I'm going to use a separate index to refer to which row I'm in and which column I'm in. And I'll start with a loop that loops over all of the different row indices. So I start at row index equals 0. I keep going, well, row index is less than 3. That is the number of rows in the 2D array. I almost wrote I++ there, so you can see I'm a creature of habit. Okay, so this loop, each iteration of this loop takes care of one of the rows of my matrix Q. But what I want to do is I want to now print out the row at row index. Okay, so that means I have to then, let's say I'm at row number 1, I want to loop over all of the different columns and then print out each value. So what I want is then to loop over all the different column indices. Column index equals 0, column index is less than 2, that's the number of columns, column index plus plus. All right, and now I have a row index and a column index. So inside of this inner loop, I'm working with a single element. So I'll print out that element. And this isn't terribly different from when I print out an element when I'm looping over a one-dimensional array. So we'll print out Q at index row index, comma, column index. And then at the end of each row, I want to print out a new line because the prompt says 1 row per line. So at the end of each row, I'm going to add this \n to end the line so that when I go to the next row, I'm starting fresh on a line by itself. If I run that, that's what I get. So I get the array printed out. I have it on my diagram so I can validate that it is the correct thing. It is actually the array that I thought I constructed being printed out. Now, to come back to that thing I put aside earlier, so I've decided that the outer dimension, this one, is the row number. And that is arbitrary, but you're forced to observe that in this course for the sake of clear communication. But it's worth considering, in general, if I have to loop over a 2D array, there's no requirement that your outer loop be the loop over rows. Here it makes sense because each iteration of the outer loop is printing out one line. And if there is 1 row per line, then logically I need to make sure that the outer loop is iterating over rows. But in cases where, for example, if you just wanted to add up all of the values inside the grid, there is no reason you have to have your outer loop be the row loop. It could be the column loop. However, I do recommend to people, it doesn't seem to help anything to go back and forth, to arbitrarily flip-flop between the different modes because it's easy to forget what you're doing. Choose something, whichever thing tends to work for you, and do that. For me, I found that using the row loop as the outer loop has always made sense to me, and so that's what I do.